Okay, so we're here at the second lesson. It's Tuesday, December 7th, and we're starting off with this part that we've constrained to all three of the origin planes so that it can no longer move around. It's stuck in place. And the reason that we did that is this is going to be the spine of what we're building, which is the X drive. So this is where we're going to start everything off of. So since we're building a drive, let's get the other parts in here just so we can kind of organize everything. So since this is the front, it's best to just keep it organized in that way. So I'm going to go up to place, and I'm going to scroll through. Let me go to the toolbox that we downloaded. So I'm going to go down to structure, and let's select the 1 by 2 by 1 by 25 bar, also called a 5 bar. So we have that, but this isn't the orientation I want it with. I want it in, so I can right click it and rotate it 90 degrees. So let's rotate around the Y and then around the X. And we'll place one right here. And we'll go over here. And let's rotate around the Z 2 more times so that the flat face is looking in. So let's start with those two. I'm going to turn off the visibility of these planes just so that it's easier to work with. So now as you can see, these can still move around, and we don't want that, but this one's stuck, so we want to constrain it to this one. So that's what these little green circles are for. But I actually found a way to do it that's better this weekend, where instead of green circles, they're going to be blue now. So yeah, it's going to be a bit confusing, but let's start with that. So in order to constrain something, it's best to have two circles and constrain them along their axes, because that gets rid of two translational degrees of freedom. Because if there's a circle on this square right here, and a circle on this square right here, and I constrain them around their axes, then it can no longer move this direction or this direction. So one constraint gets rid of, technically that's 1, 2, 3, 4 degrees of freedom. So that's why we want to use circles instead of squares. So in order to do that, we're going to click on the part that we want to add the circles to, and then right click it and click open. So this opens the file. So now we're in this view, and just mess with the view cube till you get it in a way that looks okay. So then we're going to come up to the top left and click Start 2D Sketch. And you're going to click on this face right here so that it starts the sketch. Now we're drawing on top of a 3D part right now. So we're drawing on this plane right here. And what we're going to want to do is this is one of the squares that we want to constrain something to. So we go up here to project geometry, and that basically takes something from another spot in the 3D plane and it brings it to the surface that you're drawing on. So we'll click that, and we want to click 3 lines that are on the sides of the square. You don't need to do 4, you just need the 3. So you want to click the 3, and that brings the line geometry of this edge forward to our drawing plane. So then we go up to circle and you click the down arrow because we don't want a center point circle, we want a tangent circle. And this function right here makes it so that you click these three lines and it creates the circle. And the circle is tangent to all three of these lines, so the center point is in the center of the square. So now that creates the circles that we need. But since we're going to be constraining it on both sides, we have to do it on the bottom as well. So the same process, let's do it one more time. We go up to project geometry. We select the three lines. And then we go over to circle. Tangent circle won't immediately be selected, so you click the down arrow and you click tangent. And you click the three lines that are around the area. And now when you scroll out, you can see that we have the circles on the top and the bottom. So we click Finish Sketch. And we go back to the assembly on the bottom, the assembly that we were working on. And as you can see, the circles are in there now. So then we can use those circles to constrain it now. Do I need to repeat anything? Do you guys understand this? Okay, I'm going to keep going then. So for simplicity right now, okay, so I'll go back to the sketch part and redo that. So we have to, so we were on this part, we were working on it. So you click the part and then right click and open it. Now we created a sketch on this plane because we need to draw these circles on it, because the circles make it so that we need less constraints to connect two parts together. So we create the circle in order to create less work later on. So if you go to the sketch over here in the browser, if you right click it, edit sketch, you can add circles for every single hole. You don't need to, you only need to do it for the ones you're working on right now. But I'll do another set just to show you. So you click project geometry up here. You click on three of the lines around the edges. Then you click down and you go to tangent circle. And you click the three lines that you just projected onto the drawing plane. And it creates a circle that is tangent to all of the lines. So then you can just do the same for any of the holes that you have to constrain. Does that make sense? Yeah, exactly. So we finish the sketch, click finish. It updates in the assembly. So as you can see, those two holes that we drew are there now. So let's go to the top view and let's line these up. So we're going to constrain it like this. So at the end of this first 5 holes, we're going to constrain it. And at the end of this first 5 holes, we're going to constrain it. So now let's zoom in. So if we were building this in person, you would take a screw and you would go through this hole and through this hole, and then you'd put a nut on the other side. But since we're not building it in person, instead we can just take the two circles and constrain them by their axes. So we go up to the ribbon up top and we click the constrain button, and that brings up the constraint menu. And then we're going to click the first circle. So as you can see, when I highlight it, I can see that the axis is selected. You want to make sure that you're picking the axis and not accidentally like one of these lines or just the center or something. You want to make sure that's the axis. So you click the first axis. Then you click the second axis. And now it switches it to two circular objects being constrained. It's always best to go with undirected because then you won't get any errors if you have to flip something otherwise. So this first direction means that this piece is in its current position and the other piece is in this position. And then if you did this, it would flip this circle to the top, rotating this piece right here. But then if you click undirected, it can go this direction, or it can rotate and go the other direction. So we're going to click apply. And as you can see, it brings the two circles together. So those two circles are now together. So as you can see, it rotates around that axis that I just constrained. So if we look at it from the top, those two circles are constrained around each other, and the bars are stuck together. Now the problem is, it's still rotating. So next we're going to constrain these two circles next to each other so that it no longer rotates. So once again, you go up to constrain, you click this circle's axis and this circle's axis, and then click undirected. And when you click apply, it sets the constraint but leaves this menu up for you to do something else. When you click OK, it accepts the constraint and then closes the menu. So let's click OK. And as you can see, now it made the constraint. So when we look at it from up top, you can see they're both there, and it no longer moves around anymore when I click it and drag it. But when we look from the side, it still goes up and down. So it's still not fully constrained. So then our last constraint, after we've put these two axes together, is to mate this face on top to the face on the bottom right here, so that they're touching, because if they were screwed together, they would be pulled together. So we go to constraint again. We're still using this first constraint that it comes up with automatically. We click this face right here, and then we have to change the view so we can see the bottom. And we're going to click this face right here. As you can see, it shows a preview, and they are stuck together. So let's click OK. And as you can see now, it no longer moves, and the two pieces of metal are together. So this piece is now fully constrained, and it won't move around anymore. Does that make sense to everybody? Okay, so we're going to do the same thing with the other side. just to show it to you one more time. So we have our two sets of circles. We know that this circle corresponds to this one, and this circle corresponds to this one. So let's constrain the first one. Click the first axis, then click the second axis. Click undirected, and then click apply so we can keep our menu open. And as you can see, these two circles are they're really close to each other, but we know they're not constrained because we just did this one and we haven't touched this yet. So what you can do is you can highlight over it. You can see that you're selecting one of them, but you don't really know which one. But you can click it anyway. And as you can see, when I highlight over it, it picks up the other circle that's on top of it, but we can't see it. So you can click that one, and that constrains them together. So even though they looked like they were constrained, they actually weren't, but we just made them constrained. And then it still goes up and down, which we want to stop. So we hit constrain one more time. We click the top face, rotate the view cube, and click the bottom face. And then click OK. So now we have a frame that we're going to continue building off of. And everything is tight, because as you can see, when I click it and drag it, it no longer moves. I'll take a break right here for anybody to, if they need to catch up doing these steps, or if they have any questions. Nobody? Okay, so if you have a constraint and you mess something up and you want to get rid of it because that's not what you ended up wanting to do, you click the part that the constraint is on, and you come over to the browser. So as you can see, when I click the part, it highlights in the browser on the left. So then you would click the down arrow, and there's a list of all the constraints here that part uh, has on it. So if I click the first one, you can see that first axis that we constrained. And then if you click the other one, you can see the second axis we constrained. And if you click the next one, you can see the two faces that we constrained. So let's say that like you messed up the two faces or something. You just right click the constraint and delete it. And now that constraint no longer exists, but the rest of the constraints, like these two circle constraints, they still exist. But this mate constraint no longer exists. So that's how you would delete a constraint if you messed up. Or if you like changed your design and wanted to edit it. And a reminder, it'll give you save reminders, so remember to always click save. And if you have an assembly, it'll show you all the parts inside the assembly. So when you save an assembly, it saves every single file inside of it too. So you can just click OK, and that'll save the assembly file, and it will save this C channel file as well. Did you have another question? Which program are you using? Okay, so if you grab the part to move it, and the part moves but the circles stay where they are, that's most likely. Did you draw it inside of the assembly, or did you draw it inside of the part? Okay, can you share your screen? Okay, so if you did inside the assembly, it's constrained like the drawing is relative to something in the assembly. It's not actually on the actual part. That's why it's always best to just open the part separately, so that when you make the drawing, it will actually put it onto the part and the drawing will stay relative to the part. So to make sure that you do it on top of the part, click the part in the file you want to do the drawing, and then right click it and click open, and then click on the top left right here where it says start 2D sketch, and then select the face inside of the part file, not the assembly file. Does anybody else have a question? Okay, well, I'm going to continue on then, unless anybody wants me to pause for a minute in order to catch up inside of their CAD file. Okay, then I'll continue. So since we're making an X drive, there's one part that's integral to the design of an X drive, and that's the angled wheels. So in order to angle these wheels, we have to use a part. Since we're in Vex, we have to use a Vex part, because that's the only legal parts other than polycarbonate, which you can make custom gussets out of polycarbonate, but then you have to design them, which is not that hard to do. I've done it, but it's easier if you can just take a part that's already been created and add it on. So let's go to place, and they should be in structure, but I'm not sure if this library that we downloaded actually has the gussets that I'm looking for. Okay, so it doesn't look like they have the gussets, which means that, okay. So now I'm going to show you how to get the gussets that you need in order to create this part. So you're going to have to go to Google and go into the browser and search V5 products, or you could say Vex V5 products, and it's the first one that shows up. Click products-v5-vex, and this takes you to the Vex website where you can see all of their stuff. So on the top up here, we're going to hold our cursor over products, and then since it's a gusset, it's a metal piece, so that's structure. So this brings us to the store with all of the structure pieces that Vex sells. So this is what we're looking for, these gussets right here. So you click on the part, and as you can see, the pieces we want. So you can scroll down, and this is their description of the parts. So you can go to details, kit contents. See, they're talking about stiffening a chassis, which is what we're doing with these parts. Material type. So if you wanted to like do some material analysis to see how much force your wheel would have to get hit with in order to bend this, just to make sure that it won't break or it won't bend over time, you can get all that information here. You can get their weight if you want to calculate the weight of your robot. But then what we're interested in is the CAD files. So as you can see here, there's a CAD file for every single thing. So the one that we want is the 45-degree flat gusset. So I always like to click preview just to make sure I'm downloading the right thing. Oh, that's not the right thing. See, that's why I like to click it. Oh, here it is, 45-degree gusset. Yeah, this is the one we want. So this brings up a little, I think this is a Fusion 360 preview or something. So that's the part that we want, this one right here. So then you're going to click download. And that downloads the part. But it downloads a step file, which is okay. But that's just something that you have to remember, that it's downloading a .step file instead of a .ipt file, which is what Inventor and Fusion 360 use. So once we download our file, then we're going to go back to Inventor. And we're going to go up to the top left and click place. And you're going to have to go at the top of this pop-up box. There's a bar that says look in. So you have to click down on that. And you have to click downloads. And as you can see, there's the 45-degree gusset that we just downloaded. So click that. Oops, I double clicked. Make sure that it gets highlighted, and then click open. And another pop-up comes over here on the left side. And that's basically because it's opening a step file. So it's converting it when it opens it from a step file to an IPT file, which is really useful because you don't have to actually do anything. So then you click OK, and it converts it. And then as you can see, it appears on our cursor for us to place it, just as if we had taken it from a regular IPT file. So we're going to start with one of these on each corner. Then I'm going to press escape to get that off of my cursor. So let's start with this back corner right here. So when we're placing this, we have to let's get each of them kind of into position. So this one's going to go like this. This one goes like that. This one goes like that. This one goes like that. So it's best to kind of get them into position before you start. So now let's constrain this back one first. So these gussets are good because they already start with the circles. So you can just go to constrain and make sure you click the axis. You don't want to click this because when you click this top and it's just a green dot, then you're constraining that center point and you're not constraining the axis. So you want to make sure you hold the inside of this edge to constrain the axis. Then click this axis down here. And this is one of the best places to make sure that you click undirected. Otherwise, you'll get a lot of issues. So as you can see, this is kind of in a weird angle. And we want it to be like this, but flipped. So it's a good thing that we picked undirected because we'll be able to flip it when we get to that step. So if we constrain the other one, and click undirected, this is the opposite angle that we want it. But since we clicked undirected, this face would be touching this face if it was flipped in the direction we wanted it. So you can do just that. You can click this face, and it rotates it because we clicked undirected on those axis constraints. So let me click OK, and now this is screwed into place. Now if you were building this in real life, you'd have another one on the bottom right here. So you would have one on the top and one on the bottom. We can do that eventually, but we don't need to do it right now if we're just getting the basic design down so that we can see how it would work. So now let's do the front. I'm just going to raise this so that it's in the right position. So this circle right here is missing, but we need it to constrain it. So that means we're going to have to add the circle there. So let's click this part, right click it, click open. Now you guys have to click new sketch because you've never made a sketch on this part. But I've already made the sketch on here. So I can just right click it and edit sketch. But you guys would have to click create new sketch and select this face right here. So now since I know I had the two holes next to each other on the other side, so I know that this side is the one I have to constrain. So let's go down to it, project geometry, click three of the edges, click tangent circle, and then you get the circle that you need. So then finish sketch, bring it back, constrain, one axis, the second axis. And now since this is kind of hidden, I'm going to click OK, so that then I can rotate it around so I can see it better. Constrain this one, and this one, undirected. Now constrain this face, and this face, and click OK. Oh, okay, so if this troubleshooting thing comes up and it says assembly cannot be solved with a yellow exclamation mark, just click cancel operation. I think it's because I messed up one of the constraints. So if I right click the constraint and I click edit, yeah, see, it's opposed. I forgot to click unaligned. So if I just click unaligned and click OK, it updates it. Then I click constrain. There we go. So now it's two of them down. Do I need to go over anything again? Or do you just want to see me do the other two and then that'll show you how to do it again? Okay, I'll just go do the next two and then we'll stop for questions. So we already have the circles here because you should have drawn the circles over there and these two pieces are reversed. So constrain, pick the inner axis. Oops, I clicked the wrong thing. I clicked a corner instead. So what I can do is just click cancel, constrain. Make sure I click the axis this time. Make sure you click the one without any arrows that says undirected. And I can't see the circles, so I'm going to have to pull it out again. And now that one's done. Now let's do the last corner. It hit itself, so I'm just going to click OK instead so that it goes away and I can grab it. Now we want to get this one. There you go. Now that one's done. So now we have our chassis with our 4 brackets on it. Does anyone have any questions or want me to go over anything? Nobody? If you need me to stop for a minute, because I know that you guys have to draw the sketches. Well, I already have the sketches drawn there, so if you need me to stop for a minute, just let me know and we can take a break while you guys catch up. Okay, if nobody has anything to say, then I'll continue. Okay. So now the next part, um, you kind of just guess at it when you've already built an X drive before, so that's the right size, but I'll show you guys how to calculate it correctly. So we're gonna go and import another part. So we're gonna go back to our kit of parts, and we're gonna get a motion piece. I don't know why the part isn't showing up. Oh, there it is. Yeah, that's what I thought. I don't know. Let me check which folder wheels are under. Are wheels under structure? Maybe wheels aren't in here. Okay, I guess wheels aren't in here, so we're gonna have to download them. Okay, that's fine. This just is another opportunity to show you guys how to download stuff. So back on the Vex website, you can go under products again, and I think wheels are under motion. So if you just scroll down, yeah, here's wheels. So this shows you all the types of wheels. So you have 2.75 omnis, 3.25. Then you have 4-inch. Then there's small friction wheels. I don't think we have any of these traction wheels yet. Then these are the regular wheels. I wouldn't advise using these on anything. And then you have these traction wheels. We have a version of these. Yeah, this is the version we have. We have these inserts at school, so you can make these wheels if you want. Then there's mechanism wheels. So since we're building an X drive, you have to use omni wheels because the robot's gonna be, see, this is an H drive, so it can move sideways and forward, but it doesn't have the rotation while translating ability that the X drive has. So go to CAD files and let's take some 4-inch omni wheels. These are what we have the most of. So as you can see, we have the wheel here. So then you click download, and it'll start its download in the bottom of your browser. And then once it completes its download, you can go back to Inventor. So now we're going to place the imported CAD file, navigate to downloads, click the thing that you just downloaded so it's the most recent one. It might take a second to load. Okay, so when the menu pops up on the left, to convert it, just click OK. And then it'll take a second to load. You'll have the green bar right here that says it's importing the file. And then the wheel comes onto your cursor. So we're going to need 4 wheels. So let's look at it from the top. Right click and rotate on the Z. So 1, 2, 3, 4. Then come to the top left and click free rotate so that we can get them into kind of the right angle. So as you can see, this isn't very square. It's rectangular. So you need to fix that if you're making this an actual design, because an X drive needs to be as square as possible. Otherwise, when you rotate and you drive, it will skew itself as it drives because the wheels won't be around the center of mass evenly, and it just causes a lot of issues with friction and stuff. So these bars would have to be shortened if you are actually making this correctly. But I just picked a random bar size in order to show you how to CAD it. Oh wait, no. Sorry. I skipped a step. Um, what you should do first is you should click these. So we can open them. So we're opening the wheel file, and as you can see, there's a whole bunch of parts over here, but those don't really matter. We don't need to worry about those. What we're going to do is we're going to create a new file. So click File, hover over New, and then click Assembly. And now let's insert the wheel. Where did the wheel end up? Oh, here's a cool trick that you can do. So I have two assemblies and I want to move one part from another, but I don't want to deal with the file links. So like, if I don't want to try to find this file where it is in my computer, but I want to get it to this other assembly, what I can do is Autodesk Inventor works as a browser. So you can come over here and you can click Restore Down, and it's a web page, basically. So then you have your other pages over here. So this is my assembly page. So I can put my assembly page right here, kind of like if you had two Chrome windows. And I can have my X Drive page right here. So this is one file, this is the other file. And when I click on them, you can see the browser updates on the left side. So I have the wheel. I can just drag it and drop it over there. So I never actually have to find the file where this wheel is being located. I can just drag it and drop it. It's pretty useful. And then if you want to go back, you just click full screen on this, and then it switches everything back to full screen. So anyway, we're in this file, and as you can see, this wheel has this like hole in the middle, and the axles are smaller than this hole. This hole is the size for a high strength axle, but we usually use a low strength axle. So what we need to do is we need to put an insert into it. The inserts should be under structure in the library. I just need to find them. Maybe they're under motion. Oh, here it is. So this is the green one that says free spinning gear insert. That's not the one we want, but that's one that you could use if you were using a screw joint, so that's something you can free rotate. We're looking for where is it? Um, it's called a metal gear insert. And I don't know where it is. Um, anyway, if you can't find something, the best thing you can do is just go back to the website and download it. So I'll show you how to download it then. So we go back to the website, scroll back to the top. If you don't know which one it's under, you can just search it. So we're looking for the gear inserts. It's probably under the axles. Yeah, the ones on the left are what I'm looking for. So we scroll down, you go to CAD files, and we're looking for metal shaft inserts. The metal ones are square for some reason, and the plastic ones are circle. I don't know why they're different materials. Even though the metal ones last longer, so they should really just make them both out of metal. So now that we found the file, we just click download. Once it downloads, you can go back to Autodesk now. Go to Place CAD Files, navigate in the top where it says Look In to Downloads, and just click Metal Shaft Inserts. And click OK when it's on the import window. As you can see, it comes on your cursor. So we're going to need two of these, one for each side. So we're going to then constrain them. Click one face of the insert, then click one face of the wheel, and click OK. So let's move this one over. So this, as you can see, it's right here. What did it constrain to? And as you can see, whatever I constrained it to, it's not what I wanted it. So I can just right click the mate and delete it. What I meant to do, oops. When you get something like this, it's because the file's too far away. So you just have to search for it. So like, as you can see, there's like that tiny little white blob. That's the insert that somehow got shot across. So you just have to drag it back and then click home again. So let's try that again. Let's constrain one part of the gear insert to the inside. There we go. Oh, I did constrain it right. I realized what's happening. So when you go, since this wheel's at an angle, it looks weird. So that's why it looks like it's going through, but I think it's actually constrained. I'm not sure though. Anyway, let's continue with the top. So we're going to constrain the top of this to the corresponding top inside of the wheel. So right here. And click OK. As you can see, now it only goes forward and back. There we go. As you can see, it's only going inside and outside of the wheel. So now let's drag it back a bit. And now let's constrain this face. Oh, there we go. I'm just going to scroll in on it. It's going to get constrained to the face of this insert. And as you can see, it puts the two faces together. And now that's inserted onto it. And you just do the same with this other insert. Just grab a random face, and grab one of those, then click OK, drag it out. Let's constrain this face to the corresponding side. And let's constrain the last face. Oops, that wheel's covering it. To that one right there. And as you can see, it goes in. So then we'll click OK. And you got 2 inserts in there now. I forgot to save this file, but you should save it and you should call it 4-inch Omni inserted. I've already done this before. So I have, let me just find mine. Yeah, see, I've done 2.75 inserted, 3.25 Omni inserted. Oh, I don't actually have a 4-inch Omni inserted. That's interesting. Okay, I guess I'll be saving it here then. So I'm just going to call it 4_omni_inserted so that I know that this file has the inserts in it. And it'll show you all the dependent saves. So just click OK. And in the bottom left, you can see that it says it's saving. Then the name changes and it says ready, so you know it's saved. So now this wheel is much more useful than it was before, but there's still one more step that you need to do. So let's right click this metal shaft insert and open it. And then let's start a 2D sketch on the outside, right there. Let's do the same thing. Project geometry of the 3 corners. And then click the tangent circle. And now you have a circle on it. Make sure you save it. And now the Omni wheel has a circle on it, which is going to make it way easier to insert into things. So now if we go all the way back to our X drive, and we save the X drive, you'll see all the Omni wheels will update with what we've been doing previously. Oh wait, sorry, no they won't. We have to delete these Omnis out of here. Because these Omnis are the part file, we want to insert our assembly that we just made. So let's go to place imported CAD files and navigate to wherever you saved the file of that, what's it called, of that assembly. So then you click the assembly that you saved, and now insert those. And now when you look at it, you can see the inserts that you added with the circles in them, which will make our job much easier. So these wheels, we need to make sure they're not going to rub, because that's one of the main things that causes an X drive to fail. So you're going to want to set them about right there. Now we need to know what metal piece we're going to put on the outside to connect these. So go to place and just pick any metal piece, preferably a shorter one. So go to structure in the library and just pick something like the 1x2x15. And let's go to a top view, zoom in on one of the wheels. Let's right click it. You want the flat part to be by the wheel. And now let's take that and rotate. And let's hold that up to the dots. So this is going to show us how much we need to come out, because we don't need anything past here, right? Really, you don't need anything past the hole, but you need to secure it somehow, so usually you would cut it about right there. So let's constrain this one. Okay, now that's constrained. So let's see what hole it lines up without hitting this corner. So you want to get it close, just so that you're not wasting space, because remember you have to build this inside of 18 by 18. So as you can see, this is going to have to come up. But that angle actually looks pretty good. That inserting it in that hole right there. So let's look at the top just to make sure there's no issues with it. Now, if you had the room in your 18-inch requirement, just to be safe, I would move it one more, but it's probably fine right here. So let's look at where that hole was. So we're thinking about inserting it right there, which would be about 1 bar out, which is usually how much it takes for a 4-inch wheel. So then what we'll do is we will constrain, angle it. You can angle the view cube if you need to be able to get a bit of a better view, but we'll constrain that axle, and then we'll constrain the axle of the wheel, make sure it's undirected, and then click OK. So now if you look at the top, this wheel is on that axle, but as you can see, it's still going to be able to rotate, which a wheel still, of course, will be able to do. And remember, you're going to have to put spacers in here, because if you just put the wheel flat, it'd be like that, and the wheel needs to be like right there. So that is basically the bar length where you're going to need it at. So you know that you can copy that for all 4 of the other wheels. So you can make its own part file where it's only a 1 bar, which I've done, or you can do what I'm about to show you right now, which is you go to 3D model, you start a 2D sketch, you click this face right here of the part. So now, about your question earlier about making a sketch inside of an assembly, this is really only one of the only times you would do it. So we're in the sketch and it's on the face of this part. So that I can make a rectangle, and I can go right here, and then each of these bars I know is 2.5 inches, so I can just say that's 5 inches. And this, I'll just make it 3/4 of an inch, so it's a close size. What is this? Oops. Okay, so this box act. Oh wait, no, there we go. Okay, so then I'm gonna use the project geometry tool again, and I'm gonna project the geometry of this edge. Then I'm gonna use the collinear constraint, which makes 2 lines go on top of each other so that they're collinear. It's different than a parallel constraint because they can't just be parallel, they have to be touching. So click the one you projected and click that line. And then you can just drag this on top. And you can finish the sketch. And then when you hit extrude, since this is the only sketch in the feature, it'll automatically be chosen. And if you extrude it just enough that it cuts everything, which is 1 inch, then you wait for it to load, because it's cutting a feature inside. It cuts it as if you had cut the piece of metal in real life. So as you can see, we only need that last hole where the wheel is, so that it can rotate about that. But then we just cut that piece off because we don't actually need it. So now you can't see it in the file anymore. So now you just do that the same. You do that same thing for all 4 corners. But then see, if you had the piece in there and you right click and dragged it down, it's still going to have the same part. So you'd have to make 4 cuts, which is a bit annoying, which is why the other thing that you could do is just make a new part. So if you go into your files and you go to the library, okay, so if you go into your file explorer and you go to wherever you've saved the library, you can do something like this where you take the C channel, right click it, copy it, then right click right next to it and click paste. And as you can see, it makes the copy file. So we'll right click that, go down to rename it, delete the copy part, and we're going to make a 5-bar. So just rename it to C channel 1 times 2 times 1 times 5. And double click that, and that will open it inside of Autodesk. So then now you can see it's open in here. So you can do the same thing. You can make a sketch. This is a different part now. We've made a copy of it. So this is a different part than what's in the library. And you can make the same rectangle and then dimension it to be 5 inches by 3/4. Project the geometry of that edge, collinear the 2 pieces, and click Finish Sketch, Extrude. So as you can see, you can change the direction of this little tab. So if it's going up, we don't want to add that material. You can just reverse direction, and now it'll take away the material. Then click OK, and save this part. And now the part fills its namesake that says it's a 1x2 by 1x5. So then you can go back and now you can insert that new part. And we can do the same thing where you bring the 2 files like this. And you, so I click on this file, so it's the dominant one, right? I go up here and highlight this part, and then I drag it into there. So if you're putting a part into an assembly, open up the part, click on it, go into the browser and click the part at the very top and drag it in. And now we can close that. Let's make this big again. And now we'll put one of these on each corner. And now let's constrain them. Um, we want the flat side to go towards the wheel so that there's less things that could go wrong with it. And as you can see, it's not going that direction right now. So this is very important that you pick unaligned for the constraint right there, because we're going to reverse it. So then you click the other one. And now, if you look at the bottom, this is the side we want to be touching the gusset. So we click that side. Then we click the bottom of the gusset. And as you can see, it flips it. So I click OK. And then we can constrain the wheel onto it. So this last circle is the one that it's going through. As you can see, it's now on there. And you just do the same for the other 4 wheels. Pick the edge. Pick this edge. And now we have to look at the bottom. This is the side we want to be touching. And it rotates it. And this is the wheel. And this is the circle. And now you've done another one. And now you just have one more to go. And now this one's in the right direction already, the flat side's there. So this is the one we want to touch the gusset. Now you do the same thing, you grab the wheel and the hole, and you constrain their centers. And there you go. Now you have the outer part of each of these wheels. And they're constrained to those centers. So that's where I'm going to end the lesson for today. Hopefully this was helpful to you guys. And we'll pick up right here on Thursday.